A-level physics, paper 2, dielectric constant is 8. Okay, so I've seen quite a few questions now asking about this. What does that mean? Okay, so if it's got a dielectric constant of 8, first thing we look at is that equation on your formula sheet, and it says capacitance is equal to its area, so area or the cross-sectional area of the plates, times by ER times by E naught, divided by D, which is the distance between the plates. So we're going to talk through this equation and what you'd actually write in your exam, okay? But remember, you can always join us for exam masterclass. It's 59 quid and it was for 15 hours of lessons. We've already started, but you get access to all the previous recordings. So join us and we do exam practice the night before your exam, and we do some a few days before, giving you workbooks to help you prepare. We do it for OCRA and AQA. So just click the link in the description there in the bio to join us. So capacitance, obviously, we're talking about capacitors. So we've got our two capacitor plates. So A is our cross-sectional area of our capacitor plate. D is the separation of the two capacitor plates, the distance between them. We have ER and E naught. So epsilon naught, that's the permittivity of free space. Okay, so the permittivity of free space basically just means like how easy it is to form an electric field. And if we're talking about a vacuum, that number is on your formula sheet, okay? ER is what we're talking about, our dielectric, okay? So the epsilon with a sub R. So that's our dielectric constant. So here it's going to be 8. So you can see if we don't have a dielectric, right? If we didn't have a dielectric, it would be this equation. But because we do have a dielectric, what we're doing is we're multiplying the whole equation by a factor of 8. So what the dielectric does is it increases the capacitance of the capacitor by a factor of 8, okay? So if we can increase the capacitance of the capacitor, what that means we can store more charge on its plates. Okay, so what we write in our exam, what is the dielectric constant of 8? What it means is that it increases the capacitance of the capacitor with a factor of 8, and if there was no dielectric, okay? And the better way to write it is you want to say that the relative or the permittivity of the dielectric divided by the permittivity of free space, we could say a vacuum, is equal to 8. That's what it is. Okay, so like basically permittivity, we're talking about how easy it is to form these electric fields. But again, what you want to just write is the permittivity of the dielectric divided by the permittivity of free space or vacuum is always going to equal to 8. So in the next video, we're going to go over exactly what a dielectric is. But hopefully you're thinking the dielectric is that material we put between the capacitor plates. And normally what we pop in here is things called polar molecules. So polar molecules might be something like water, because polar molecules means one side will be slightly positive, one side will be slightly negative. And then what they do is they line up the capacitor plates. So say this plate was all negative and say this plate was all positive. The dielectric will go in here and it will align itself against that field. So that's the negative side. The polar molecule will put its positive towards here. So you can see that overall this side will become slightly less negative. So that's why you can put more charges onto the plate.